Thanks everyone for coming tonight. I was really motivated to put this talk together because I have been extremely dismayed by the level of public policy discourse in this country on the subject of biofuels. The discourse in the magazines, newspapers, radio, TV is highly biased. It's full of inaccuracies. It's incomplete, and it is a very poor basis to decide what the energy future of this country is going to be. So what I hope to do tonight is to look at some of the science behind biofuels and to look at the very real physical, economic, environmental, ecological, and other limits that there are to developing this as an alternative to oil. About the only thing that we don't have a limit for with respect to biofuels is the political rhetoric. And so what I want to talk about tonight are some of the hard facts around biofuels that you hopefully can take with you when you see this kind of recently dead or somehow other converted. Throughout human history, mankind has largely lived on biofuels. This is not a new thing to the 21st century. But of these three main types of biofuels, solids is what has provided the solar energy needed for mankind throughout most of its existence. What's really different about what we're preparing to do now is that we are attempting to move it into a liquid phase. And the liquid phase is because we are looking at it as a replacement for oil for transportation. In some parts of the world, gaseous biofuels are already widely in use. China has about 70 million biodigesters that produce methane on small scale for households. If you go up to the Sonoma County dump there, you'll see all the pipes coming out of the ground that are extracting the methane from the rotting biomass there. So the solids and the gaseous has been around for a long time. What's new is turning it into a liquid. So,
let me know if you want the lights down.
Can everyone see okay?
No, can't really see it too well.
Okay.
What was TDP?
DTP is thermal depolymerization. It's a technique of taking biomass and turning it into a liquid under high pressure mechanics. So, why is this even an issue? Why are we rushing into biomass? Why is corn-based ethanol the flavor of the day? And there's two interrelating situations in this regard. First, as you can see on the left, is what U.S. oil demand is by sector. Everything you see in blue, or light blue here, is oil that's used for transportation purposes. 3/4 of all the distillate, that's diesel, used in this country is used for transportation. That's what keeps most of our freight system going in the rail system. Jet fuel, of course, is the aviation system. Motor gasoline is almost entirely used in motor vehicles for transportation. Among the residual there is heavy fuel oil that's primarily used for large ships, and then a little sliver of other stuff which is largely aviation gasoline that fuels the small planes. So in total, this country is enormously oil dependent for its entire transport system. Over 65% of all the oil we consume is consumed for transportation. The second trend is shown over here, and this is the outlook for production of world oil and gas. What we're looking at is within the next few years, if not already, the production of conventional crude in the world will peak and begin a decline. This is a geological inevitability. It's not going to be offset by technology, higher prices, or smart people in oil companies. This is just the way that finite resources play out when you extract them over a long period of time. This chart's kind of interesting because it combines oil and gas together. Regular oil, as you see here, this being 2007, That peaked in 2005, and that's widely acknowledged. And that's the beautiful stuff. That's the cheap, light, sweet oil that comes out of the ground on its own, under its own pressure, sold for very cheap prices, and is what provided the energy that built the 20th century. What we're moving into now that's not quite peaked is the heavy stuff, the tar sands, the shells, the bitumens and stuff. And then what we have left is the deep water. Deep water is a very, very expensive oil. And because it's so expensive, oil companies drill it, pump it at its maximum rate because they have to get a return on their capital. So within the next few years, this whole slew of petroleum is going to peak, and we're going to, we're seeing already the first phases of that just through the price rises in the last few years. Now, biofuels are not the same as petroleum, and it's very important to keep some distinctions in mind between what a biofuel is and what a petroleum product is. One of the major distinctions is what's called energy density. Biofuels do not have the same amount of energy per unit mass that petroleum fuel does. In biodiesel's case, 1/5 less. In ethanol's case, it only contains about half the energy that gasoline does. And so what you see here is these really high figures, like diesel, 48 megajoules per kilogram. So, we don't normally use megajoules in this country, so just for comparison, a typical person, our energy needs, a male in this country is considered needing about 2,500 calories per day, and a female about 2,000 calories per day. In megajoules terms, that's 10 megajoules per person per day for a male, 8 megajoules for a woman. So what we see here is that in the case of diesel, it would take 1 kilogram of diesel, that's 2 pints of diesel, contains enough energy to keep, equivalent to what a human needs to keep itself alive for 4 days. That's how much energy is packed into natural petroleum. And what we're finding with biofuels is it simply doesn't have that amount of energy. So biofuels, the liquids we're dealing with today are primarily ethanol as a gasoline replacement or blend stock, and biodiesel made from a variety of things. So I want to focus a little bit on what is this hype behind ethanol, and we'll talk about biodiesel as well. In ethanol, all we have proven as a production method today is the first kind, the starch and sugar-derived ethanols. This is ethanol derived from corn, from cassava, sorghum, taro, sugarcane, any plant that has a large amount of starch in it. Starch is basically what's called a polysaccharide. It's a long-chain sugar, and we break those long chains up into simple sugars like glucoses and fructoses, and then we put yeast in it, and it ferments it, and it makes an alcohol. Normally, we use that in the form of beer or wine or vodka, but in this case, we get a very pure ethanol from the fermentation of the sugars in all of these plants. The second one is the cellulose derived. This is the so-called switchgrass-based ethanol, the ethanol that's going to be the fuel of the future. This is a much more complex and challenging issue because cellulose is the constituent of a plant, and it's also a complex long-chain polysaccharide. However, nature doesn't like to give us those polysaccharides, so far we've not found an economic way to actually turn it into a sugar, to then add the yeast, to then ferment it and distill it and turn it into ethanol.